Okay, students, I believe that you are doing great. So we are beginning our term 2 of our academic year 2021. Unit 1 will be about ratios. Understand that in primary 6, you talked about ratios and you know how to solve some problems involving ratios. Okay? So we are going to begin from what you looked at primary level as we move on to the advanced level of ratios. Okay. Now, a ratio is used to compare two or more quantities of the same kind which are measured in the same unit. So when we are comparing using ratios, we are comparing two or more things, okay? But these things must be having the same unit, and they must be of the same kind, okay? For instance, if we are comparing height, okay, let's say we have like two children. We have this one. Don't mind about my drawing. It may not be that perfect, but I just want to show you something. Okay, another student. Okay, and we say that the height of this student is 120 centimeters, and the height of this one is, let's say, 100 centimeters. Now, see the key point. The key point is that the units must be the same. That's why this is centimeter and this one is centimeter. Okay. But if, let's say, this one is in feet, then we cannot compare them. To compare them, then we must convert feet to centimeters. Then we go ahead to compare them. So that's why we are saying that the units must be of the same kind. So they must be having the same unit. Okay, now we can see that we have centimeters and centimeters. Now, to write this as a ratio, then we will say that we are having 120 to 100. We don't include the centimeters because a centimeter and a centimeter will give us 1. So just assume that we will write it as a fraction. We will have 120 out of 100, and of course centimeters, and then this centimeter will cancel with this centimeter. So we will remain with no centimeters. So it means that now we are having 120 out of 100. So that's why we don't have units when we are talking about ratios. Now, to write this as a ratio, we will say that it is 120 to 100. Now, if this student is A and this student is B, so we say that the ratio of A to B is 120 to 100. But the ratio of B to A will be 100 to 120. So we read 100 to 120. Then the ratio of B to A, 100 to 120. I believe you have got an insight of what ratios is all about. I know that this already, you talked about it in grade 6. Okay. Now let's talk about equivalent ratios. I will also talk about what you looked at already in grade 4 or grade 3 or grade 5. You talked about equivalent fractions. So equivalent fractions, these are fractions that are equal, okay? As in looking, once you look at them, they will not be, you will see that they have different values, but these fractions will be equal. Now, for instance, in part 1, we are having 6 out of 12. Now, to get another equivalent fraction, or to get a fraction that is equal to 6 out of 12, we can say, okay, let's divide 6 by 3, so that we also divide 12 by 3. Now, this will give us 3, because 6 divided by 3, we will get 2, and 12 divided by 3, we will get 4. Now you see that we are getting 2 out of 4. Now, 6 out of 12 is equal to 2 out of 4. So these two, we call them equivalent fractions. But also we can go ahead and divide this by 2 and 4 by 2. And then this will give us 1 out of 2, because 2 by 2, you get 1, and 4 by 2, you get 2. Now, we go ahead and say that still 6 out of 12 is equal to 2 out of 4, and again equal to 1 out of 2. Or you can say a half. Now, these, we call them equivalent fractions. I believe you remember that. And of course, we know that this one is the simplest form, the level at which you cannot reduce that fraction. We call it simplest form. Now, similarly, we can write this as 6 to 12. When we write it as a ratio, we say that this is equal to 2 to 4, and again equal to 1 to 2. So that is what we call equivalent ratios. So we can say that this is equivalent ratio. You can say this is equivalent ratios. So 6 to 12 is equal to 2 to 4, equal to 1 to 2. And now, remember that 1 to 2 is the simplest form. Simplest form. The simplest form, as I've told you already, it is that ratio that cannot be reduced further. So that is the simplest form, and now that is what we call the equivalent ratios. Now, when we are having 2 out of 3 in part 2, if we need to get equivalent fraction, we can say, okay, let's multiply, let's say by 2, and 3 by 2. So remember that you multiply by the same number. So this will give us 2 times 2, that is 4, and 3 times 2, that is 6. So 4 out of 6. So you see that 2 out of 3 is the same as 4 out of 6. You see? And if we need to get another equivalent fraction, we can go ahead and multiply, let's say, by 3. So this will give us 4 times 3, that is 12, and 6 times 3, that is 18. So again, we say that this is equal to 12 out of 18. So you can continue and get many other equivalent fractions. Now, to write this as ratio, we simply have to say that 2 out of 3 is 2 to 3. 4 out of 6 is 4 to 6. And 12 out of 18 is 12 to 18. That's all. So these are equivalent ratios. Equivalent ratios. Okay. Now, let's see, how do we find equivalent ratios? You see, from what we have done here, you can see that here we were using division, but here we are using multiplication to get these equivalent ratios. So, in short, we can use multiplication principle and division principle. Okay, let's get another example. We see how to use multiplication principle. Okay, use multiplication principle to find two equivalent ratios for the ratio A 2 to 5, B 4 to 3. Okay, now remember, to use multiplication principle, we just need to multiply by the same number. Okay, let's begin with A. So we can say we are having 2 to 5. So we say that this is equal to, we have 2 times a certain number to 5 times a certain number. This number must be the same. Let's say that, okay, we will multiply by 3. So we multiply by 3 here and multiply by 3 here. Okay, and this will give us 6 to 15. Okay. Now, remember, we need two equivalent ratios. So this is the first one. Now we need another one. So we can say, okay, still 2 to 5 is equal to 2 times a number, 2, 5 times a number. Okay, now we have multiplied by 3. Let's say, okay, this time let's multiply by 4. So the rule is that you multiply by the same number. Okay, now this will give us 2 times 4, that is 8, and 5 times 4, that is 20. So the two equivalent ratios will be 6 to 15 and 8 to 20. So we can say that the ratio 2 to 5 is equal to 6 to 15 and equal to 8 to 20, just like that. Okay, let's try part B, where we have 4 to 3. We need two equivalent ratios. Okay, we are having 4 to 3. So let's get the same number that we can multiply with. Let's say we multiply by 2. So we get 4 times 2 2, 4 times 2. Okay, you see, the same number I'm talking about is 2 and 2. Here you see 3 and 3. Here you see 4 and 4. You understand that? So we say that this will give us 4 times 2, that is 8. Sorry, here we have got 3, not 4. Okay, 4 times 2, that is 8. And 3 times 2, that is 6. So we have 8 to 6. Then let's get another, because we need 2. So 4 to 3 is equal to 4 times, let's multiply by 3. 4 times 3, 2, 3 times 3. So you can see we are having 3 here and 3 here. Same number, okay? So we are having 4 times 3, that is 12, and 3 times 3, that is 9. So we can say that finally, 4 to 3 is equal to 8 to 6 and equal to 12 to 9. So these are the equivalent ratios. Let's see how we can use division principle. Okay, now we can say 15, let me use another color. Okay, 15 to 45 is equal to, now also the rule is that we are going to be dividing by the same number. So we say that we are having 15. Let us divide it by 3 to 45 divided by 3. So you see, we are having divided by 3 and here divided by 3. So we come up with 15 by 3, that is 5, and 45 by 3, that is 15. So we have 5 to 15. Since we need to get 2 equivalent ratios, so let's again divide. So we say that we are having 15 by 45. So this is equal to 15. Let's divide it by 5 this time. So 45 divided by 5. So you can see we are having divided by 5 here and here divided by 5. So now we say that this is equal to 15 divided by 5, that will be 3. And 45 divided by 5, that will be 9. You see? So we conclude and say that 15 to 45 is equal to 5 to 15 and equal to 3 to 9. So these are equivalent ratios. Now let's get the last part for our lesson of today. We need to get 2 equivalent ratios of 12 to 18. So we are having 12 to 18. Let's say that we will start by dividing by 2. 12 divided by 2, 12 divided by 2, 18 divided by 2. So this will give us 12 divided by 2, that is 6, and 18 divided by 2, that is 9. Okay? All right. Now let's get another. So we have 18 divided. So we have 18 to, sorry, we have 12 to 18. So this will be 12. We need to get a number that is divisible by both 12 and 18. So let's say 12 divided by, let's say 3. 12 divided by 3 to 18 divided by 3. So this will be 12 divided by 3, that is 4, to 18 divided by 3, that is 6. So we are having 4 to 6. So finally, we say that the ratio 12 to 18 is equal to 6 to 9 and equal to 4 to 6. Okay, I hope you have understood how to use division principle and multiplication principle to find equivalent ratios. Okay, now I want you to go to page for your practice. Go to page number 6, page 6, and you do practice now, question 1 and 2. Practice now, question 1 and 2. Question 1 and 2. Practice now, question 1 and 2. So when you finish that, you go to exercise 1A. You also do question number 1 and question number 2. Exercise 1A, you do question 1 and question 2. So we will stop here, and when we meet next time, we are going to see how do we tell that these two ratios are equivalent. How can we know that the ratios are equivalent? Here we have been finding equivalent ratios using division principle and multiplication principle. Now, next lesson, we will see how can we know that these two ratios are equivalent. So we stop here for today and we meet again next time. Thank you and goodbye.